Hello students, already we have seen preparation of phenol from this haloarine, then from benzene disulfonic acid. Today we are going to see in detail preparation of phenol from benzene diazonium salts. So phenol is synthesized from benzene diazonium salt. Before going to study a phenol synthesis from this, we are going to study a preparation of a benzene diazonium salt from aniline. So here aniline is treated with the nitrous acid to form here this is nothing but HNO2 plus acid HCl. It at a temperature 273 to 278 Kelvin. It will give us this benzene diazonium chloride, and 2 water molecules. So here there is a formation of this water molecule and one more water molecule with this OH and H of this HCl, and we will get here this N2 plus and Cl minus. So this is the benzene diazonium chloride. It is synthesized from aniline, and this process is called as diazotization. So here how this nitrous acid, that is HNO2, is formed here. When NaNO2 is mixed with HCl, we will get HNO2 plus NaCl. This is HNO2 nitrous acid, is nothing but I have written here ONOH just to show a elimination of water molecule to water molecule, but this is HNO2, and this is prepared from mixture of this NaNO2 plus HCl. We will get this, and that will be reacted with aniline in presence of HCl at 273 to 278 Kelvin temperature, and we will get here benzene diazonium chloride, and this reaction is called as diazotization. After this diazotization, after preparation of this benzene diazonium chloride, this is converted into a phenol just by water hydrolysis. So first step is diazotization, and second step here this benzene diazonium chloride is converted into phenol just by water hydrolysis. So that azo group will be replaced by here OH, and here elimination of nitrogen dioxide along with HCl. So this is benzene diazonium chloride. This is converted into phenol. So this is how phenol is synthesized from benzene diazonium chloride just by water hydrolysis, and this benzene diazonium chloride is prepared or synthesized from aniline, that is primary amine. When it is treated with nitrous acid, we will get, that process is called as diazotization. we'll get benzene diazonium chloride, and that benzene diazonium chloride we can easily convert it into a phenol just by water hydrolysis. This is the one of the method of preparation of phenol. Next we are going to see a fourth preparation, that is preparation of phenol from Tumin, that is nothing but isopropyl benzene. Phenol is synthesized from Tumin. Tumin is isopropyl benzene. Isopropyl benzene is called as Tumin. So it involves two steps. First step, that is step 1. This is a conversion of, step 1 is conversion of Tumin to Tumin hydroperoxide. Tumin to cumin hydroperoxide, first step. And second step is cumin hydroperoxide is converted into a phenol. So first step is conversion of cumin to cumin peroxide. So here, as I told you, it is isopropyl benzene. So benzene attached to a isopropyl group. This is cumin. This is oxidized at 403 Kelvin temperature. Here we will get peroxide this is a step 1, and steps 2 here. This is cumin hydroperoxide. Step 2 is conversion of cumin hydroperoxide to phenol. So cumin hydroperoxide is formed in first step, that is easily converted into phenol just by on heating with the dilute sulfuric acid at 373 Kelvin temperature. Here it will give us a phenol plus acetone as a byproduct. So here this will be involved in the preparation, this formation of this is involved, that is this bond will come here and this will attack to this oxygen and will get OH directly substituted to benzene, and this acetone we will get as a side product or byproduct. So here this is a cumin hydroperoxide. After heating with the dilute H2SO4 we will get here phenol and acetone. This is the fourth synthesis of phenol from cumin. by dehydration method. Alcohols are converted into a ether by dehydration method. Then these alkyl halides are converted into ether by Williamson's synthesis. And phenol is converted into ether. It's treating with much. Ethers are synthesized from alcohols just by dehydration method. Alkyl halides are converted into ether by Williamson synthesis. Phenol is treated with NaOH, and then it will form sodium phenate or sodium phenoxide. That sodium phenoxide will be treated with alkyl halide to get a aromatic ether. So these are the three reactions we are going to see which produces ether by different methods. Ethers are synthesized from alcohol, and preparation of ether by dehydration of alcohols. So here we are going to see a ethanol, that is CH3 CH2OH. Ethanol is converted into alkene as well as ether. These reaction conditions are different here. It can be converted after dehydration, it is converted into alkene, that is ethene, or there is a formation of this ether. We will get diethyl ether. So here it depends upon the reaction condition. So ethanol is dehydrated to ethene in the presence of sulfuric acid. Both is in presence of sulfuric acid, but the reaction condition, that is it 443 Kelvin. At higher temperature it is converted into ether, whereas when it is treated with H2SO4 at little lower temperature, that is 413 Kelvin temperature, it is converted into diethyl ether. So at a different reaction condition, a different temperature, when ethanol is treated with, that is alcohol is treated with the acid, that is H2SO4, it will give either alkene or ether. It depends upon the temperature. So ethoxyethane, this is a product. Ethoxyethane is a IUPAC name. Common name is diethyl ether. This is ethanol and this is ethene. It is converted into ethene. So just by dehydration of alcohol we will get either alkene or ether. It depends upon the reaction condition. So let us see its mechanism here, formation of this ether. So in this mechanism we are going to see, this is a general reaction. We are going to see a mechanism in detail steps of this reaction. First step, formation of ether is a nucleophilic bimolecular reaction, that is SN2. It undergoes SN2 mechanism involving the attack of alcohol molecules on the protonated alcohol. So step 1, that is in the first step, this is the step 1, CH3 CH2 OH that is first step is protonation of alcohol, we will get protonated CH3 CH2 OH. Protonation, it will, after donation it will have a positive charge, and this is called protonated alcohol. First step, this protonated alcohol will be converted, it will attack with another alcohol ethanol molecule. So CH2O, here it is, I will write this way, it is having positive charge. Now this lone pair will attack to this carbon, and this, it will neutralize positive charge, and we will get here, with the loss of water molecule, plus H2O, and this will have positive charge because it has donated lone pair. So this is the second step, and in the third step, this protonated ether undergo deprotonation just to neutralize the charge. This, there is a minus H plus deprotonation, and we will get here ethoxyethane, or it is also called as diethyl ether, with loss of this proton. This is a 3 steps mechanism which gives ether from alcohol, dehydration of alcohol. So here there is a loss of water molecules to get this ether from alcohol. These are the 3 steps involved in this synthesis, and this is a SN2 mechanism. This is SN2 mechanism. Ether is synthesized from this method. It is an important laboratory method for the preparation of symmetrical and unsymmetrical ethers. In this method, alkyl halide is allowed to react with sodium alkoxide. So general reaction is alkyl halides are X, that is nothing but alkyl halide. When it is reacted, when it react with sodium alkoxide, it will gives ether, and sodium halide as a side product. So if these R is the same, identical, we will get here symmetrical ether. If these R group, that is alkyl group, is not identical, we will get here unsymmetrical ether. So this is alkyl halide, sodium alkoxide, we will get here ether and sodium halide. This is sodium halide. This is a general reaction of a Williamson synthesis of ether. So sodium alkoxide this sodium alkoxide, when it is treated with methyl bromide, it will gives us so here in this sodium alkoxide, this alkyl group is tertiary alkyl group, here it is primary. We will get here a symmetrical ether, and along with this there is a side product sodium bromide. Br is taken here and bromide, this will combine together to form a salt sodium bromide. So better results are obtained if the alkyl halide is primary. If this alkyl halide is primary, we will get a better result. But if it is a secondary and tertiary alkyl halides, then elimination reaction competes over the substitution reaction. Instead of substitution, it will undergo elimination reaction and we will get alkene as a product instead of ether. So similar way, phenols also converted into a ether, and that we are going to see here. Phenols will be converted into a the sodium phenate salt or sodium alkoxide, that is nothing but here sodium phenate, and we will get aromatic ether. So phenol when it is treated with NaOH, we will get sodium phenate. This is a sodium phenate, and this when it is treated with any alkyl halide Rx, it will give us a aromatic ether. Substitution reaction where we will get aromatic ether and there is a side product, that is NaX. So phenol phenol is when it is treated with sodium hydroxide, we will get sodium phenoxide, and this sodium phenoxide when it is treated with alkyl halide, same, this is also a Williamson synthesis method, but here phenol is taken as a starting material. So that phenol, with the help of this phenol, we will get here aromatic ether. So these are the all different methods of synthesis of ether from alkyl halide, from phenol, and from this alcohols